everyone, this video is for section 5.2, applications of exponential functions. We're doing questions on investment. There are two equations that you should be familiar with. So one equation deals with compounding continuously. And one will deal with compounding interest in different time periods. Excuse me. So whether it is monthly, quarterly, daily, yearly or annually, bi-weekly, so on and so forth, you will use this first equation in A. So our first question says Dolores invests $5,200 in a new savings account, which earns 5.7% annual interest, compounded monthly. What will be the value of her investment after 9 years, rounding to the nearest cent? Notice that it said compounded monthly. That means we're going to use equation A. Okay, so in this case, we don't know the final amount, so we will leave that blank. That's A. We do know that the principal amount is $5,200. We also know the rate is 5.7% annual interest, so we convert that to a decimal, 0.057. We put in compounded monthly, meaning n is equal with 12. And then our exponent is going to be, once again, 12 from this n here, times the number of years, which is given as 9. We can literally evaluate this all in our calculator, being careful to make sure that we multiply the exponent. And you should end up to the nearest cent with approximately $8,674.99. Okay, question 2 is a little bit more tricky. In question 2, we have Jaquan hopes to earn $1,100 in interest in 3.1 years' time from $55,000 that he has available to invest. To decide if it's feasible to do this by investing in an account that compounds quarterly, he needs to determine the annual interest rate such that an account would offer for him to meet his goal. What would the annual rate of interest have to be, and rounding to 2 decimal places? So a couple of things here. It looks like we don't know the annual interest rate. It also looks like we know our initial investment, but we don't really know our final. We are told that he wants to earn $1,100 in interest. That means that our final amount is going to take our principal amount and add to it $1,100 for a grand total of $56,100 as our final amount. So we have to do a little work to figure out A. Again, we don't know R. Do we know how we are compounding? Yes. We know that we're compounding quarterly, which implies that n is equal with 4. And we also know the time, which is 3.1 years. Putting that all into the equation, we have 56,100 equal 55,000 times 1 plus the rate, which is unknown, divided by the 4 for their quarters here, to the exponent of 4 times 3.1. Okay, now this is different from the previous one. We don't have something that we can really evaluate here. We've got a variable in those parentheses. So we'll start by dividing both sides by 55,000. That'll give us, on the left-hand side, 1.02. Okay, on the right-hand side, we still have this 1 plus r divided by 4. And if we evaluate that, we get 12.1 if we multiply the 4 times the 3.1. So that's a 12.1 there. Now, you, in theory, don't know logs yet. If you do, go ahead and use logs. But what we're going to do is raise both sides to the power of 1 over 12.1. Now, we're going to do this because when we raise a power to a power, recall that we're going to multiply. So 12.1 times 1 over 12.1 will just be a 1. And we'll be left with what's in the parentheses here. So what we have then is 1.02 to the 1 over 12.1 equal to 1 plus r divided by 4. Now we're going to use a little bit more algebra to solve. So we're going to subtract by 1 on both sides, minus 1, minus 1. That'll give us a 0. And then to get r by itself, we're going to multiply both sides by 4. Okay, and so what that gives us, if we go ahead and multiply carefully in our calculator, okay, we'll have 1.04 times 1.02 in parentheses to the 1 over 12.1. If you have to put that in parentheses as well, subtracted by 1, that entire expression in parentheses multiplied by the 4. And what you should end up with is something like 0.0064. Okay, recall that an annual interest rate needs to be expressed as a percentage. And so what we do is move the decimal 2 places to the right and say that this is approximately 0.64%.